Isodrones were invited to participate in the B2Wald Project at the Biosphere 2 in Arizona in the US. And the project is taking place in a tropical rainforest, which is located basically in a massive greenhouse, and it will be dried down over several weeks. And our part is that we want to monitor how the tree water uptake changes over this drought, but also especially after the drought when we re-wet the soil again. Plant transpiration is the biggest flux on land surfaces that returns water to the atmosphere and therefore also has a big influence on climate conditions. But actually we don't know so much about how water uptake from different water sources, for example, in different soil depths, changes over time, and especially also when it comes to short-term variability. But these informations would be really important when we look at future land use changes and also climate change. We just came back from setting the whole experiment up at the Biosphere. We were there for 3 weeks, and in this video we wanted to show you on what kind of sensors we installed there, what kind of measurements we are conducting, and what everything looks like. First of all, we installed sap flow sensors in the tree. We used the heat pulse velocity method. This method gives you the velocity of water as it's transported along the tree. And later on, we can upscale that information to the amount of water that a tree takes up from the soil, transports in the xylem, and then releases into the atmosphere again. But these measurements don't give us any information about where the tree takes up its water. So for example, if it uses more shallow soil water or more deep soil water. So we also do measurements of water-stable isotopes in the tree xylem water. And we use a quite new method for this, the borehole equilibration method, where we drill a hole into the tree with an increment corer, which also gives us the opportunity to sample the xylem water right away. The hole is maybe 7-8 millimeters in diameter, and then we attach tubing on both sides. So one side of the tree borehole is connected to a bottle with compressed dry air, and we direct air from this gas bottle with quite low flows into the tree borehole. There it takes up water vapor, and we analyze this water vapor that we've taken up inside the tree with a water laser. We use solenoid valves to switch between different measurements, so between measurements of different trees or also different boreholes in the same tree, and that allows us to automate the whole system and to automatically switch between the different measurements, but also to flush the system in between measurements and therefore avoid or at least detect condensation. Additionally, we installed moisture sensors in all the trees that give us an idea on how much water is stored in the trees and how the storage changes over the drought and also with the re-wetting. What is especially exciting for Isodrones is that in our project we are focusing on the importance of deep roots for whole plant water uptake, and the Biosphere gives us a unique opportunity to label deep soil over the whole area of the Biosphere and not, as usually in field studies, only in a few specific points in the soil. And therefore we can really look into which trees have access to deep soil water and how fast they utilize this soil water, and also if they redistribute the deep soil water to shallower soil regions. Doing this experiment together with so many other researchers from different fields inside the B2Wald project gives us the opportunity to not only look on the water side and how water fluxes change over the drought, but also to incorporate information on carbon cycling and other plant physiological measurements, and that will hopefully allow us to get a better overall picture on plant physiological processes and carbon and water fluxes.